The Smalls Lighthouse tragedy. The ocean has always held within its depths both promise and peril. For thousands of years, mariners have ventured across its surface, seeking fortune, adventure, and passage to distant lands. But the sea, in all its vastness and beauty, can turn treacherous in an instant. Among the many hazards that have claimed countless vessels and lives throughout maritime history, few are as unforgiving as the hidden rocks that lurk beneath the waves, waiting to tear the hull from any ship unfortunate enough to encounter them. This is a story about such rocks. A cluster of basalt and dolerite formations that rise from the depths of the Irish Sea, approximately 20 miles off the southwestern coast of Wales. These rocks, known as the Smalls, have been the graveyard of ships for as long as humans have sailed these waters. But this is also a story about light, about humanity's attempt to tame the darkness and warn seafarers away from danger. And perhaps most importantly, this is a story about two men, both named Thomas, who found themselves trapped together in one of the most isolated places on Earth, where one man's death would become the other man's living nightmare. The tale that unfolded on the Smalls Lighthouse in the winter of 1801 would become one of the most haunting incidents in maritime history. It would change the way lighthouses were operated across Britain and beyond. It would inspire films, plays, and countless retellings. And at its heart, it remains a profoundly human story about fear, duty, survival, and the thin line between sanity and madness when one is truly, utterly alone. The waters of death. The Irish Sea has always been one of the most challenging bodies of water in the British Isles, stretching approximately 140 miles in length and varying between 60 to 150 miles in width. This sea separates Ireland from Great Britain and connects the Atlantic Ocean to the south with the North Channel to the north. For millennia, it has served as a crucial maritime highway, linking the ports of Liverpool, Dublin, Belfast, and countless smaller harbors along the coasts of England, Wales, Scotland, and Ireland. But the Irish Sea is not a gentle passage. Its waters are subject to strong tidal currents that can exceed 5 knots in certain locations. The wind patterns across this body of water can shift with terrifying speed, transforming calm conditions into violent storms within hours. The combination of these tides and winds creates sea conditions that have challenged even the most experienced sailors throughout history. The western approaches to the Irish Sea, particularly along the Pembrokeshire coast of Wales, present some of the most treacherous waters in all of Europe. This coastline is characterized by a dramatic meeting of land and ocean, where steep cliffs plunge into deep waters, and numerous rocky outcrops and reefs extend far from shore, many of them hidden just beneath the surface, invisible to the naked eye until it is far too late. For ships sailing south through the Irish Sea, the waters off Pembrokeshire represented one of the most dangerous portions of their journey. Vessels traveling from Liverpool to Bristol, or from Irish ports to destinations in southern England, had to navigate these waters carefully. The prevailing winds and currents would often push ships eastward, toward the Welsh coast, and on foggy days or during storms, it was all too easy for a captain to misjudge his position and find his vessel being driven onto the rocks. The shipping traffic through these waters was considerable, particularly during the 18th and 19th centuries. This was the age of maritime commerce, when Britain's economy depended heavily on seaborne trade. Ships carried coal from Welsh mines, textiles from Manchester and Liverpool, agricultural products from Ireland, and countless other goods. Passenger vessels transported people between the ports of the Irish Sea, while fishing boats worked the rich waters that supported entire coastal communities. But with this heavy traffic came a heavy toll. Ship after ship fell victim to the hazards of these waters. Some were caught in sudden storms and driven onto the rocks. Others simply lost their way in fog or darkness and ran aground before their crews realized the danger. The exact number of vessels lost in these waters during the centuries before reliable navigational aids were established will never be known, but historical records suggest that hundreds, perhaps thousands, of ships met their end along the Pembrokeshire coast. Each shipwreck represented not just the loss of valuable cargo and vessels, but also the loss of human life. Crews would go down with their ships, or find themselves struggling in the cold waters of the Irish Sea, where survival time is measured in minutes during the winter months. Passengers, merchants, and sailors alike found themselves at the mercy of the sea, and all too often, the sea showed no mercy at all. The economic impact of these shipwrecks was substantial. Liverpool merchants, in particular, found themselves losing significant portions of their investments to the rocks off Wales. Ships that failed to reach their destinations meant cargo that never arrived at market, insurance claims that had to be paid, and families left without breadwinners. The cost of these losses, both in human and economic terms, weighed heavily on the commercial interests of the time. It was against this backdrop of maritime tragedy that the need for navigational aids became increasingly urgent. For centuries, sailors had relied on landmarks, soundings, and their own experience to navigate these waters. But landmarks are invisible in fog or darkness, and experience, while valuable, cannot always prevent disaster when visibility is nil and the wind is driving a vessel toward unseen rocks. The solution, as it had been since ancient times, was light, a bright, reliable beacon that could warn mariners away from danger, visible from miles away, burning through the darkest night and the thickest fog. But establishing such a light on the Pembrokeshire coast presented unique challenges, particularly when it came to the most dangerous obstacle in these waters, a cluster of rocks that jutted from the sea approximately 20 miles from the nearest land. These rocks were known as the Smalls, and they were about to become the site of one of the most remarkable engineering achievements of the 18th century, and later, one of the most disturbing incidents in the history of lighthouse keeping. The Smalls, geography of peril. The Smalls are not an island in any conventional sense. They consist of a group of wave-washed rocks, the largest of which rises only approximately 3.5 meters above the highest tides. These formations are composed primarily of basalt and dolerite, ancient volcanic rock that has withstood millions of years of erosion by wind and wave. The rocks are spread over a relatively small area, with the main cluster occupying perhaps a few hundred meters at most. The location of the Smalls makes them particularly hazardous. They lie approximately 20 miles west of the Marloes Peninsula in Pembrokeshire, Wales, and about 8 miles west of Grasholm Island. This places them directly in the path of shipping traveling north-south through the Irish Sea. To make matters worse, the Smalls are not the only hazards. In this area, nearby lie other dangerous formations, including the Hats and Barrels, reefs that have claimed their own share of vessels over the centuries. The tidal currents around the Smalls are particularly fierce. These currents, known as riptides, can reach speeds that make navigation extremely difficult even for modern vessels. In the days of sailing ships, getting caught in these currents could spell disaster. A ship might find itself being swept toward the rocks faster than the wind could carry it away, and even if the crew realized their danger, they might lack the power to escape. The highest point of the Smalls barely breaks the surface of the water during high tide. This means that during storms, the entire formation can be hidden beneath towering waves. The Atlantic swells that roll into the Irish Sea can reach heights of 10, 15, even 20 meters during severe weather, and when these waves crash against the Smalls, they create a spectacle of spray and foam that can be seen for miles. But in normal conditions, particularly during high tide or in poor visibility, the rocks are nearly invisible until a ship is dangerously close. The geology of the Smalls tells a story that spans hundreds of millions of years. The basalt and dolerite that form these rocks were created during periods of volcanic activity, when molten rock pushed up through the Earth's crust and cooled. Over time, the surrounding softer rock eroded away, leaving these harder formations standing alone in the sea. The rocks themselves show the marks of this erosion, smoothed and shaped by countless centuries of wave action. The area around the Smalls supports a surprising diversity of marine life. The strong currents bring nutrients up from the deep waters, creating conditions that support fish populations and, in turn, seabirds and marine mammals. Seals are known to haul out on the rocks during calm weather, and the waters around the Smalls have historically been good fishing grounds. But for human habitation, the Smalls offer nothing. There is no soil for crops, no fresh water, no shelter from the elements. Any structure built on these rocks would have to be entirely self-sufficient and capable of withstanding the full force of Atlantic storms. The Smalls had been known to mariners for centuries before anyone seriously considered building a lighthouse there. Local fishermen knew to avoid the area, and experienced sea captains gave the rocks a wide berth. But knowledge of the danger was not enough to prevent accidents, particularly for ships whose captains were unfamiliar with these waters or who found themselves blown off course by unexpected weather. The reefs and rocks in this area create complex wave patterns that can confuse even experienced sailors. Water moving around and over the submerged portions of the reef can create standing waves, whirlpools, and areas of extreme turbulence. During storms, the entire area becomes a chaotic maelstrom of wind-driven spray and confused seas that can overwhelm vessels and crew alike. For ships approaching from the west, sailing east toward the Welsh coast, the Smalls represent a particular hazard. A captain might believe he has safely passed the known dangers of the coast only to find his vessel being driven onto the Smalls by wind and current. The rocks lie far enough from shore that they occupy a position where a ship in distress has few options for escape or rescue. The seasonal weather patterns around the Smalls add another layer of danger. During the winter months, from November through March, the North Atlantic is at its most violent. Low-pressure systems spin off the coast of North America and race across the ocean, bringing with them winds that can exceed 100 miles per hour and waves that reach heights rarely seen during summer months. The Smalls, sitting exposed in the Irish Sea with no protection from the west, receive the full force of these winter storms. In fog, which is common in these waters particularly during spring and autumn, the Smalls are completely invisible until a ship is virtually upon them. The sound of waves breaking on the rocks might give some warning, but in heavy weather, with wind roaring through the rigging and waves crashing against the hull, even this auditory cue could easily be missed. Until too late. The isolation of the Smalls cannot be overstated. 20 miles is a significant distance when measured in terms of rowing a boat or attempting a rescue in rough seas. In the 18th century, there was no radio, no way to signal for help except by visual means. A ship wrecked on the Smalls might as well have been wrecked on the far side of the world, for all the help that was likely to arrive in time. This isolation would become crucial to understanding the horror that unfolded in 1801. When something went wrong on the Smalls, help was not just minutes or even hours away. It was days or weeks away, depending on weather and sea conditions. Anyone stationed on these rocks would be utterly cut off from the rest of humanity, dependent entirely on their own resources and the hope that relief would eventually arrive. The Smalls represented everything that was dangerous about the sea concentrated into a few hundred square meters of wave-swept rock. They were a monument to the power of nature and a reminder of human vulnerability in the face of the ocean's might. And yet, paradoxically, they were also about to become the site of human ingenuity and determination, as men sought to tame this wild place and turn it into a beacon of safety. But first, someone had to decide to build a lighthouse there, and that someone had to be either remarkably brave or remarkably foolish. Perhaps, as is often the case with great endeavors, he needed to be a bit of both. The call for light. John Phillips was neither a fool nor a coward. He was a Liverpool merchant and shipowner who had built his fortune through maritime commerce. As the master of St. George's Dock in Liverpool, he was intimately familiar with the hazards of the Irish sea trade routes. He had seen too many ships fail to return to port, too many cargoes lost, too many families left destitute by the perils of the Pembrokeshire coast. Phillips was also a Quaker, a member of a religious community known for their practical approach to problems and their commitment to serving the greater good. The Quakers, or the Religious Society of Friends as they formally called themselves, had a strong tradition of entrepreneurship and innovation. They believed in taking direct action to address problems rather than simply accepting tragedy as inevitable. By the early 1770s, Phillips had become convinced that something needed to be done about the Smalls. The toll on shipping was simply too high to ignore any longer. Every lost vessel represented not just financial loss, but human tragedy, and Phillips felt a moral obligation to act. But building a lighthouse on the Smalls would be no simple undertaking. The technical challenges alone were daunting, and the financial investment would be considerable. The economics of lighthouse construction in the 18th century were complex. Unlike today, when lighthouses are typically built and maintained by government agencies, many lighthouses of this era were private ventures. An individual or group would obtain a lease from the crown to build a lighthouse at a particular location, and in exchange, they would be permitted to collect dues from passing ships. These lighthouse dues were essentially a toll that ship owners paid for. The benefit of the navigational aid. The system worked after a fashion, but it had significant drawbacks. Private lighthouse owners were motivated by profit, which could lead to attempts to maximize revenue while minimizing maintenance costs. The dues system also created resentment among ship owners, who sometimes felt they were being charged excessive amounts for what should have been a public service. Nevertheless, this was the system that existed, and Phillips would have to work within it. In 1773, Phillips formally petitioned for a lease to build a lighthouse on the Smalls. He needed permission from the Crown, which owned the rocks, and he needed financial backing from other merchants who would benefit from the lighthouse. The petition emphasized the number of ships that had been lost in the area and the economic damage these losses had caused. Phillips argued that a lighthouse on the Smalls would pay for itself through the dues collected from passing ships while also saving lives and property. The petition was approved, and Phillips found himself the leaseholder of a few hundred square meters of wave-swept rock 20 miles from shore. He had the right to build a lighthouse and collect dues, but he still faced the monumental challenge of actually constructing the thing. The Smalls presented unique engineering problems that had rarely been encountered before in lighthouse construction. Most lighthouses of the era were built on headlands or islands where there was solid ground to work with and at least some shelter from the worst weather. The Smalls offered neither of these advantages. The rocks were exposed to the full force of Atlantic weather, and the small amount of surface area available meant that any structure would have to be carefully designed to maximize the usable space while minimizing the risk of being swept away by waves. Phillips needed an engineer, but not just any engineer. He needed someone who could think creatively, who could design a structure unlike anything that had been built before. He advertised for designs, hoping that someone would come forward with a viable plan. The responses he received ranged from the overly ambitious to the patently impractical. Some proposed massive stone towers that would have cost a fortune and taken years to build, if they could be built at all. Others suggested designs that seemed unlikely to survive even a moderate storm. Then Phillips received a proposal from an unexpected source. The man's name was Henry Whiteside, and he was not an engineer at all. He was a musical instrument maker from Liverpool, a craftsman who spent his days building violins, harps, and other fine instruments. On the face of it, Whiteside seemed an unlikely candidate to design a lighthouse. But his proposal caught Phillips' attention because it was unlike anything else that had been submitted. Whiteside understood something that many of the formally trained engineers had missed. Fighting against the waves was a losing battle. Any structure that tried to block or resist the full force of Atlantic storms would eventually be overwhelmed. Instead, Whiteside proposed a design that would work with the waves rather than against them. His lighthouse would stand on tall pillars, allowing the waves to pass beneath and around the structure with minimal resistance. The concept was revolutionary. By eliminating the solid base that characterized traditional lighthouses, Whiteside's design would dramatically reduce the force that waves could exert on the structure. Water would flow through the pillars, rather than slamming into a solid wall. The lighthouse keeper's quarters and the lantern would sit atop these pillars, high above even the largest waves. Phillips was intrigued but cautious. Could this really work? Could a structure built on pillars survive the battering it would inevitably receive from Atlantic storms? Whiteside was confident in his design, though even he acknowledged that it was unproven. No one had built a lighthouse quite like this before. The question of why Phillips chose Whiteside's design over those submitted by more experienced engineers has puzzled historians. Perhaps Phillips recognized that conventional thinking would not solve the unique problems presented by the Smalls. Perhaps he saw in Whiteside's background as an instrument maker a mind trained to think about resonance, stress, and the properties of materials in ways that might apply to lighthouse construction. Or perhaps Phillips simply had faith in Whiteside's vision and was willing to take the risk. Whatever the reasoning, Phillips decided to proceed with Whiteside's design. The two men began working on the practical details of construction. They would need to assemble a team of skilled workers, gather materials, and figure out how to actually build this structure on a rock that was barely accessible in calm weather and completely unreachable during storms. The financial arrangements had to be worked out as well. Phillips invested his own money in the project, but he also sought backing from other Liverpool merchants who stood to benefit from safer shipping lanes. The Committee of Liverpool Traders, a powerful group that represented the commercial interests of the city, took an interest in the project. They understood that reducing shipping losses would benefit everyone involved in maritime commerce. The initial plan called for using cast iron pillars to support the lighthouse. Iron seemed like the ideal material, strong enough to withstand the forces it would be subjected to while also being relatively easy to work with in terms of fabrication. But this plan would soon prove to be overly optimistic, as Whiteside and his workers would discover once they actually attempted to implement it. By 1774, Phillips was ready to begin construction. He had his design, his materials, and his team. What he did not yet fully appreciate was just how difficult the task ahead would be. The Smalls would not give up their secrets easily, and the lighthouse that would eventually stand there would be built only through extraordinary perseverance and innovation. Whatever the reasoning, Phillips decided to proceed with Whiteside's design. The two men began working on the practical details of construction. They would need to assemble a team of skilled workers, gather materials, and figure out how to actually build this structure on a rock that was barely accessible in calm weather and completely unreachable during storms. The financial arrangements had to be worked out as well. Phillips invested his own money in the project, but he also sought backing from other Liverpool merchants who stood to benefit from safer shipping lanes. The Committee of Liverpool Traders, a powerful group that represented the commercial interests of the city, took an interest in the project. They understood that reducing shipping losses would benefit everyone involved in maritime commerce. The initial plan called for using cast iron pillars to support the lighthouse. Iron seemed like the ideal material, strong enough to withstand the forces it would be subjected to while also being relatively easy to work with in terms of fabrication. But this plan would soon prove to be overly optimistic, as Whiteside and his workers would discover once they actually attempted to implement it. By 1774, Phillips was ready to begin construction. He had his design, his materials, and his team. What he did not yet fully appreciate was just how difficult the task ahead would be. The Smalls would not give up their secrets easily, and the lighthouse that would eventually stand there would be built only through extraordinary perseverance and innovation. The story of the first Smalls lighthouse is, in many ways, as remarkable as the tragedy that would later unfold there. It is a story of human ingenuity confronting the raw power of nature, of craftsmen and laborers risking their lives to build something that would save the lives of others. It is also a story of setbacks and near disasters, of plans gone wrong, and hasty improvisations. Phillips could not have known, as he set this project in motion, that the lighthouse he was about to build would stand for 80 years and become profitable beyond his wildest dreams. Nor could he have known that it would be the site of an incident so disturbing that it would change lighthouse policy across Britain and haunt the imagination of people for generations to come. Henry Whiteside's vision. Henry Whiteside was a man of precision. In his workshop in Liverpool, he crafted musical instruments that required extraordinary attention to detail. The resonance of a violin depends on the exact thickness of the wood, the precise arching of the top and back plates, the careful positioning of the sound post. A difference of a millimeter could mean the difference between a mediocre instrument and a masterpiece. This background in instrument making had taught Whiteside to think about how materials respond to forces. When a violin string vibrates, it transfers energy through the bridge to the body of the instrument. The wood must be strong. enough to withstand the tension of the strings while also being flexible enough to vibrate and amplify the sound. 2. Rigid, and the instrument would be silent. Too flexible, and it would collapse under the tension. Whiteside saw parallels between these principles and the challenge of building on the smalls. A rigid structure would resist the waves until it was overwhelmed and destroyed. But a structure with some flexibility that could move with the forces acting upon it rather than fighting them might survive where a more conventional design would fail. His pillared lighthouse would not just allow waves to pass through. It would also be able to flex and sway with the wind and sea, absorbing forces rather than resisting them. The design that Whiteside proposed consisted of 9 principal pillars arranged in a circle with a central mast for additional stability. These pillars would be embedded directly into the rock of the smalls, drilled into holes and secured with molten lead. Rising 65 feet above the reef, these pillars would support an octagonal wooden hut, approximately 14.5 feet in diameter. This hut would serve as the living quarters for the lighthouse keepers. Above the living quarters, another structure would house the lantern itself. The light would sit at a total height that would make it visible for many miles in all directions. A rope ladder would provide access from sea level up to the hut, allowing keepers and supplies to be brought aboard during the rare periods when conditions permitted boats to approach the rocks. The design also called for some storage facilities to be carved directly into the rock of the smalls. These would hold coal for heating and fresh water for drinking. Without these provisions, the lighthouse keepers would be unable to survive for extended periods on the rocks. A small platform around the exterior of the living quarters would allow the keepers to perform maintenance on the structure and tend to the lantern above. Whiteside's preliminary work on the project began in the winter of 1775. One of his first decisions was to assemble the entire structure at Solva, a small Welsh harbor over 25 miles from the smalls. This would allow the team to fit all the pieces together carefully on dry land, identifying and fixing any problems before attempting the far more difficult task of erecting the lighthouse on the rocks themselves. This decision proved to be fortunate because almost immediately, problems emerged with the iron pillars. The cast iron that Whiteside had planned to use proved to be faulty. The pillars showed cracks and weaknesses that would have made them unsuitable for the extreme conditions they would face on the smalls. Whiteside made the crucial decision to switch to oak, a choice that would prove to be one of the keys to the lighthouse's success. Oak was one of the finest building materials available in the 18th century. English oak, in particular, was renowned for its strength and durability. Ships of the Royal Navy were built from oak because it could withstand the stresses of naval combat and years of service at sea. For Whiteside's purposes, oak had another crucial advantage. It was elastic. Unlike iron or stone, oak could bend slightly under stress and then return to its original shape, exactly the quality that Whiteside wanted for his design. The work at Solva proceeded through the winter of 1775 and into the spring of 1776. Whiteside oversaw the fabrication of the pillars, each one carefully shaped and prepared. The octagonal hut was built and fitted with everything the keepers would need: bunks, storage for food and supplies, basic furniture, and secure fastenings to ensure nothing would be torn loose during storms. By June 1775, Whiteside was ready to make his first attempt to begin construction on the smalls themselves. He assembled a team that included himself, 8 miners who would be responsible for drilling the holes in the rock, a blacksmith, 2 laborers, and his assistant Henry Summers. The vessel that would support this operation was a boat called the Unity, under the command of a master mariner named Essex Summons. The expedition set out from Liverpool and made its way to the smalls. When they arrived, Whiteside and his team got their first real understanding of what they had undertaken. The rocks were far more forbidding in person than they had appeared on any chart or description. The swells rolling in from the Atlantic made just getting onto the rocks a harrowing experience, and it quickly became apparent that they would only be able to work during brief periods when conditions permitted. The miners set to work immediately during the few windows of opportunity they had. Their task was to drill holes into the solid rock, deep enough to securely anchor the pillars. This was backbreaking work, done with hand drills and chisels, and progress was measured in inches. The central hole for the main mast was particularly challenging, as it needed to be deeper than the others to provide maximum stability. Before leaving the rocks to return to Solva, the workers managed to excavate a storage chamber in the rock. This space, measuring approximately 10 feet by 6 feet by 6 feet, would hold coal for the lighthouse stove and barrels of fresh water. Without this storage, maintaining the lighthouse through the winter months would be impossible. The work proceeded in fits and starts through the summer of 1776. The team would sail out to the Smalls when weather permitted, work as long as conditions allowed, and then retreat to Solva when storms approached. According to records, during a 3.5-month period from June to October, the crew was only able to actually work on the rocks for a total of 9 days. The rest of the time, they waited for windows in the weather that never came, or were driven off the rocks by approaching storms. Despite these challenges, Whiteside pressed forward. The pillars were transported to the Smalls and carefully erected in the holes that had been drilled. Each pillar had to be positioned exactly, then secured with molten lead poured into the space between the pillar and the rock. This process was dangerous in itself, as the workers had to melt the lead on the rocks and then handle the molten metal while being buffeted by wind and spray. The octagonal hut was assembled piece by piece, lifted into position atop the pillars, and secured. The lantern structure was added above the hut. By September 1776, the lighthouse was complete enough to light for the first time. 8 oil lamps, each fitted with glass-faceted reflectors, were installed in the lantern. These lamps would burn whale oil, which was the standard fuel for lighthouses of the era. On September 1, 1776, the Smalls Lighthouse was officially completed and lit. From the moment its light first pierced the darkness, it served its intended purpose. Ships passing through those waters now had a warning of the danger that lurked there. Captains could see the light from miles away and adjust their course accordingly. The lighthouse was described by some contemporary observers as a raft of timber rudely put together, but this description hardly does justice to the innovation and craftsmanship that had gone into its construction. Whiteside's design was unlike anything that had been built before, and it worked. The pillars allowed the waves to pass through as he had envisioned, and the structure stood firm even as Atlantic storms battered it. But Whiteside's involvement with the Smalls was not over. In 1777, he made a visit to the lighthouse to inspect how it was holding up and to make any necessary adjustments. While he was there, the weather turned. What was supposed to be a brief visit turned into a month-long ordeal as storms made it impossible for any boat to reach the rocks to retrieve him. Supplies ran low. Whiteside found himself facing the very real possibility of starving to death on the lighthouse he had designed. In desperation, he wrote several messages and placed them in bottles, sealing them with wax and tossing them into the sea. One of these messages read, "Being now in a most dangerous and distressed condition upon the Smalls, do hereby trust Providence will bring to your hand this, which prayeth for your immediate assistance to fetch us off the Smalls before the next spring, or we fear we shall all perish, our water near all gone." The message was addressed to Thomas Williams, Esquire, at Trellathan, near St. David's, Wales. Against all odds, the bottle washed ashore just 2 days later, almost at the very doorstep of Williams' home. A rescue was organized, and Whiteside was taken off the rocks, though the experience had clearly shaken him. He had learned firsthand just how isolating and dangerous the Smalls could be. The Smalls Lighthouse had proven that Whiteside's revolutionary design worked, though not without difficulties. The structure swayed and rocked in storms, which made life uncomfortable for the keepers, but actually helped it survive by allowing it to move with the forces acting upon it rather than resisting them rigidly. Over the years, additional struts would be added beyond the original 9 pillars, further strengthening the structure. Whiteside's lighthouse would stand for 80 years, far longer than anyone had dared to hope when it was first conceived. It would prove profitable beyond Philip's wildest expectations, eventually generating annual income of over £22,000, and it would save countless ships from destruction on the Smalls. But it would also be the scene of a tragedy that would haunt everyone connected with it and change the way lighthouses were operated throughout Britain. That tragedy was still 23 years in the future when the lighthouse was first lit. But it was coming, as inevitable as the storms that battered the rocks. The construction phase of the Smalls Lighthouse stands as a testament to 18th century engineering ingenuity and the determination of the workers who risked their lives to build it. Every aspect of the project presented challenges that had rarely, if ever, been encountered before in lighthouse construction. The men who took on this work did so knowing that the odds were stacked against them, yet they persevered. The logistics alone were daunting. Every piece of material, every tool, every supply of food and water had to be transported 20 miles across open ocean to a rock that offered no natural harbor or shelter. The Unity and other vessels that serviced the construction had to time their approaches carefully, waiting for the brief windows when the sea was calm enough to allow boats to come alongside the rocks. The miners who drilled the holes for the pillars performed some of the most dangerous work. They had to position themselves on the wave-swept rocks, often being secured with ropes to iron rings that had been driven into the stone. Specifically for this purpose, the work required them to swing heavy tools while maintaining their balance on slippery, uneven surfaces. One mistake, one moment of inattention, could result in a fall into the sea or being crushed against the rocks by a wave. The drilling technology of the time was primitive by modern standards. The miners used hand drills and chisels, pounding steel into solid basalt and dolerite. The rock was extraordinarily hard, resistant to the tools. Progress was measured in fractions of an inch per hour. Each hole needed to be at least 18 inches deep, and there were 9 of them to drill, plus the central hole for the main mast, which needed to be even deeper. The noise must have been tremendous. The crash of waves against rock, the howl of wind, the constant ringing of steel on steel as the miners hammered their drills. Communication between workers would have been difficult, necessitating hand signals and practiced teamwork. The spray from the waves would have kept everything perpetually wet, making tools slip in hands and surfaces treacherous underfoot. When it came time to erect the pillars themselves, the challenges multiplied. Each pillar was a substantial piece of oak, heavy and unwieldy. Getting them from the boats onto the rocks required careful coordination and considerable physical strength. Once on the rocks, each pillar had to be maneuvered into its designated hole, positioned perfectly vertical, and then secured. The decision to use molten lead as the securing agent was both practical and dangerous. Lead has a relatively low melting point compared to other metals, making it possible to melt on-site with equipment that could be transported to the rocks. Liquid lead flows easily and conforms to irregular surfaces, creating a strong bond as it cools and solidifies. But handling molten metal in such an exposed location presented obvious risks. The workers had to set up a small forge on the rocks to melt the lead. They had to protect this forge from wind and spray, while also ensuring adequate ventilation to avoid breathing dangerous fumes. Once the lead was molten, it had to be carefully poured into the space between the pillar and the rock, all while wind-driven spray threatened to cool and solidify the metal before it could properly fill the gap. The timing of the work was crucial. The structure was vulnerable during construction before all the pieces were properly secured. If a storm struck while the work was only partially complete, the entire structure could be destroyed, along with weeks or months of labor. The team had to work as quickly as possible during favorable weather, knowing that conditions could deteriorate without warning. Food and water had to be hauled up to the workers each day they were on the rocks. There was no place to store supplies until the rock-cut chamber was completed, so everything needed had to be brought from the boats. This added another layer of logistics to an already complex operation. The workers had to be fed and hydrated while also accomplishing their construction tasks. The physical toll on the workers must have been immense. They were subjected to cold, wet conditions, constant wind, and the stress of working in such a dangerous environment. Falls were a constant risk, as was hypothermia if someone ended up in the water. The workers had to trust their equipment, trust their fellow workers, and trust that the structure they were building would justify the risks they were taking. Safety protocols as we understand them today did not exist in the 18th century. There were no hard hats, no safety harnesses beyond ropes tied around waists, no modern first aid kits. If someone was seriously injured, the only option was to get them to shore as quickly as possible, weather permitting. If the weather did not permit, injured workers would have to endure as best they could until conditions improved. The psychological aspect of the work should not be underestimated either. The Smalls were remote, isolated, and obviously dangerous. The workers knew that they were far from help if something went wrong. The surrounding sea represented a vast, indifferent force that could kill them in moments if they made a mistake or if their luck ran out. Yet, they returned to the rocks day after day, whenever weather allowed, to continue their work. The installation of the lantern at the top of the structure required particular care. This was the whole point of the lighthouse, and if the lantern structure failed, the entire project would be worthless. The lantern had to be positioned securely, protected from wind and spray, while also allowing the light from the oil lamps to shine unobstructed in all directions. The 8 oil lamps that were initially installed represented the state-of-the-art in lighthouse illumination for 1776. Each lamp burned whale oil, which was expensive but provided a bright, relatively steady flame. The glass-faceted reflectors behind each lamp helped direct and concentrate the light, making it visible for greater distances. These lamps would need constant attention from the lighthouse keepers, requiring regular trimming of wicks, refilling of oil, and cleaning of glass and reflectors. When the lighthouse was finally complete and ready to be lit, there must have been a mixture of relief and pride among everyone involved. They had accomplished something that many had thought impossible. Whiteside's innovative design had been realized, despite all the challenges and setbacks. The Smalls lighthouse stood as a beacon against the darkness, a testament to human ingenuity and determination. But the completion of construction was just the beginning of the lighthouse's story. Now it would have to prove itself against the full force of Atlantic weather. The true test would come during the first winter storms, when waves would crash against the pillars and wind would shriek through the structure. Would Whiteside's design hold? Would the pillars stand firm? Would the oak prove strong enough and flexible enough to survive? As it turned out, the lighthouse would indeed survive. It would sway and rock in storms, making life uncomfortable for the keepers, but it would stand. Over the years, it would be strengthened and improved. Additional struts would be added to the original 9 pillars. In 1817, the lighting system would be upgraded, doubling the number of lamps to 16 and installing more efficient silvered parabolic reflectors. The lighthouse would be repaired after storms, maintained, and continuously improved. For 80 years, Whiteside's lighthouse would stand on the Smalls, guiding ships safely past the rocks. It would save countless vessels and unknown numbers of lives. It would generate substantial income from lighthouse dues, making Philip's investment eventually profitable despite his initial financial struggles. And it would earn a place in engineering history as one of the first successful pile lighthouses, a design that would be copied and adapted for maritime structures around the world. But along with its triumphs, the Smalls lighthouse would also become the site of one of the most disturbing incidents in maritime history. The very isolation and harsh conditions that made building the lighthouse so challenging would create the circumstances for a tragedy that would change lighthouse policy throughout Britain and haunt the imaginations of people for generations to come. Life of a lighthouse keeper. To understand what happened on the Smalls lighthouse in 1801, we must first understand what life was like for lighthouse keepers in general during this period. The profession was unlike any other, requiring a unique combination of skills, temperament, and dedication. Those who took up this calling knew they were committing themselves to a life of isolation, hardship, and constant vigilance. The primary responsibility of a lighthouse keeper was deceptively simple: keep the light burning from dusk until dawn, every single night, regardless of conditions. This single duty encompassed an enormous amount of work. The oil lamps of the period required constant attention. The wicks needed to be trimmed regularly to prevent smoking and to maintain a bright flame. The oil reservoirs had to be refilled before they ran dry. The glass panes of the lantern needed to be cleaned frequently, as salt spray and soot from the lamps would quickly reduce the brightness of the light. In addition to tending the light itself, keepers were responsible for the mechanical systems that kept everything running. Many lighthouses had clockwork mechanisms that rotated the lamps or reflectors to create a distinctive pattern of flashes, helping mariners identify which lighthouse they were seeing. These clockwork mechanisms needed to be wound regularly, and the weights that powered them required constant adjustment and maintenance. The fog signals presented their own challenges. The bell that had been installed at the Smalls could provide a warning to ships when visibility was poor, but it required someone to ring it regularly. During heavy fog, a keeper might spend hours manually operating the bell, unable to rest or sleep while fog persisted. Later, more automated fog signal systems would be developed, but in the early years of the Smalls lighthouse, sounding the warning bell was manual labor. Weather observation was another duty that fell to lighthouse keepers. They were expected to record wind direction and strength, visibility conditions, sea state, and any unusual weather phenomena. These observations were valuable to maritime authorities and helped build a better understanding of weather patterns in different regions. The logs that keepers maintained provided a record of their activities and observations that could be reviewed by inspectors. Maintenance of the lighthouse structure was an ongoing requirement. Wood needed to be painted or oiled to protect it from the elements. Metal fittings required cleaning and oiling to prevent rust. Ropes and rigging needed inspection and replacement. The living quarters required upkeep. In short, there was always something that needed attention, and keepers were expected to maintain their lighthouse in good condition at all times. The daily routine of a lighthouse keeper was dictated by the needs of the light and the weather conditions. In summer, when nights were short, the light might only need to be tended for a few hours. In winter, when darkness lasted 15 hours or more, the keeper's work stretched through most of the night and into the early morning hours. Sleep had to be taken in shifts, with one keeper always on duty to ensure the light continued to burn. The living conditions at most lighthouses were Spartan. Space was limited, and the accommodations were functional, rather than comfortable. At the Smalls, the octagonal hut that served as living quarters measured only 14.5 feet in diameter. In this confined space, the keepers would sleep, eat, store their supplies, and spend their off-duty hours. There was no privacy, no opportunity to escape from one's companion even for a moment. Food was a significant concern for lighthouse keepers, particularly at remote locations like the Smalls. All food had to be brought in from shore, and the keepers depended on regular relief boats to replenish their supplies. The diet was monotonous and heavily weighted toward foods that would keep for long periods: salted meat, hard biscuits, dried beans, and root vegetables. Fresh food was a rare luxury, available only briefly after a relief boat arrived with provisions. Water was even more critical than food. A human can survive for weeks without food, but only days without water. At the Smalls, fresh water had to be stored in the rock-cut chamber that had been excavated during construction. The keepers had to carefully ration their water supply, always mindful that the next relief boat might be delayed by weather. Bathing was minimal, limited to salt water when possible to conserve the precious fresh water for drinking and cooking. Heating and lighting the living quarters presented challenges of their own. Coal was heavy and took up considerable storage space, so it had to be used sparingly. The keepers might keep a small stove burning during the coldest weather, but fuel conservation was essential. During winter months, the living quarters would be cold and damp, with the keepers huddling in whatever warm clothing they could manage. Personal hygiene was difficult at best. There were no bathrooms in the modern sense. The original Smalls lighthouse predated the introduction of flush toilets to lighthouses. The keepers had to make do with chamber pots and buckets, emptying waste into the sea. Washing was done with cold salt water most of the time, as heating water required fuel and fresh water was too valuable to use for bathing. The psychological aspects of lighthouse keeping were as challenging as the physical ones. The isolation was profound, particularly at offshore lighthouses like the Smalls. During winter months, relief boats might only visit once every few months, weather permitting. The keepers were completely cut off from the rest of humanity, with no news from home, no letters, no contact with anyone except each other. Cabin fever was a recognized problem among lighthouse keepers. Being confined in a small space with the same person for months on end tested even the most congenial relationships. Small annoyances could become major grievances. Personality conflicts could escalate into genuine hatred. The lack of privacy, the inability to escape from one's companion, and the monotony of the routine could drive men to the edge of sanity. Some keepers coped by establishing rigid routines and maintaining disciplined schedules. The structure of regular duties helped provide a sense of order and purpose. Others found solace in reading, writing, or hobbies that could be pursued in the limited space available. Some kept journals or wrote letters that would be sent whenever the next relief boat arrived. The relationship between keepers at a two-man station like the Smalls was critical to the success of the operation. The men had to work together, trust each other, and maintain a reasonable level of civility despite the stresses they faced. When the relationship worked well, the keepers could support each other through the difficult times, sharing the burden of isolation and hardship. When it did not work well, life could become a special kind of hell. Lighthouse administrators tried to match keepers carefully, pairing men who were likely to get along. But personality conflicts were inevitable, and when they arose at a remote lighthouse, there was no easy solution. The keepers could not simply quit and go home. They were committed to completing their tour of duty, which typically lasted several months. They had to find a way to coexist, even if they could barely stand each other. The fear that all lighthouse keepers lived with was the possibility of being forgotten. If the organization that operated the lighthouse went bankrupt, or if there was some administrative failure, relief boats might simply stop coming. The keepers would be abandoned on their rock with dwindling supplies, no way to signal for help, and no hope of rescue. This fear was not entirely unfounded. There were instances of keepers being stranded for extended periods when relief was delayed by administrative failures or financial problems. The physical dangers were constant as well. Falls were a major risk, particularly when climbing the exterior of the lighthouse to tend to the lantern or perform maintenance. The sea was always waiting to claim anyone unlucky enough to lose their grip or miss a step. Fires were another constant threat. With oil lamps burning constantly and limited means of fighting a blaze, a fire at a lighthouse could be catastrophic. The weather could turn deadly without warning. Winter storms in the Irish Sea could generate waves that crashed entirely over structures like the Smalls lighthouse. The keepers might find themselves trapped inside the hut, listening to the thunder of waves and the shriek of wind, hoping that the structure would hold. Even minor leaks could be serious, letting in cold seawater that had nowhere to drain in the confined space. Despite all these challenges, there were men willing to serve as lighthouse keepers. For some, it was simply a job that paid reasonably well and offered steady employment. For others, it was a calling, a sense of duty to help protect mariners from the dangers of the sea. And for some, perhaps, it was an escape from troubles on shore, a chance to leave behind whatever problems or complications their lives had held. The keepers who were assigned to the Smalls lighthouse in the winter of 1801 were two men named Thomas Howell and Thomas Griffith. Like all lighthouse keepers, they knew what they were getting into when they accepted their assignment. They understood the hardships, the isolation, the risks. What they could not have known was that their tour of duty on the Smalls would become one of the most infamous incidents in lighthouse history, a story of death and madness that would be retold for generations to come. Thank you so much for joining me on this journey through one of maritime history's darkest chapters. If you found this exploration of the Smalls lighthouse tragedy as fascinating as I did researching it, please consider hitting that like button and subscribing to the channel. There are so many more stories of mystery, tragedy, and the unknown waiting to be uncovered, and I'd love to have you along for those explorations. Let me know in the comments what aspect of this story struck you most deeply. Was it the ingenious design of Whiteside's lighthouse, the unimaginable psychological horror that Thomas Howell endured, or perhaps the way this single tragedy changed lighthouse policy for nearly 2 centuries? Your thoughts and reflections always add another dimension to these stories. Until next time, sleep well, and remember that even in our darkest moments, there are lights that guide us home.